All right, guys. Make sure you finish with E and F, and here's G and H. Okay, let's see. Camila says the single transformation must have been a translation 8 units to the right. Ew, no. How did this one become this? How did this guy become this guy? No, we didn't move 8 units to the right. That's not right. All right, hint. Look, if this was the mirror, this point went to there, this point went to there, and then it went to there. If this was the mirror, it's 2 away from the mirror, so its reflection is 2 away from the mirror. This guy, his reflection is 7 away from the mirror, so his reflection is 7 away from the mirror. And this is the x-axis. That should be a hint. 2. Okay, in all these problems, I see line segment DE is translated 5 units up and 5 units to the right to form the new segment. What's the distance between D in distance of where it's the new D and the new E? Okay, so I don't even have to move this. You see how this is halfway between the box? Well, that's right here, and this is right here at -5. So how long is this line if it goes from 5 to 9? Let's think. If I just move it somewhere else, if I move it 5 units to the right and 4 units up, it's going to be somewhere like, I don't know, like over here somewhere. But it doesn't change its length. So however long it is here, it is over here. So how long is that? Oops. Number 3. All right. How did I get down here? Did I reflect across the y-axis? Did I reflect across the x-axis where this is 7 away so that its reflection is 7 away? No. Or did I just basically take the guy on bottom and slide it straight up? All right, let's see. Number 4. Consider the following. How did I get there? Okay, let's see. If I take ABC and make it 7 units up, so A would go to 1, 2, 3, 4, 5, 6, 7, and then reflected it across the y-axis. Okay, so here's the y-axis. So then I'd be 1, 2, 3, 4 from the y-axis. So 1, 2, 3, 4. Yeah, A ends up at A. All right, let's see if B ends up at B. 1, 2, 3, 4, 5, 6, 7, and then it's 2 away from the y-axis. So then I go 2 away. Yeah, it is right there. What about this guy? 1, 2, 3, 4, 5, 6, 7, and it's 1, 2, 3, 4, 5, 6 away. So it ends up 1, 2, 3, 4, 5, 6 away, and all the corners match up with the right letters. Yeah, that works. Okay, let's see. The next one. ABC is translated 7 units down, so just take this triangle. No, if this moves down, we're going to be way down there. And then followed by a reflection across the y-axis, we're going to be over here somewhere. Maybe if they went up. Okay. Triangle ABC is reflected across the y-axis, so it goes this way. And then you go 7 units down. I don't know. That should be pretty obvious that that's not where you end up. Number 5. I'm going to use this graph over here to help us with number 5. FG begins at 2, 1, which is right there, and ends at 2, -6, which is right there. Okay, this is a straight line, straight up and down. We can just count boxes. 2, 3, 4, 5, 6. You should know how long that line is. Even if we just slide it, I could slide this anywhere. It's still going to be the same length. So remember, all we're looking for is did they dilate it? Dilation is the only thing that will change its length. So since they didn't, I don't even care where it goes. I know it's the same length. All right, number 6. Let's see. Given this figure, how did this happen? Well, here's where it started. How did we move down there? Did we reflect across the y-axis as the mirror? Well, you tell me. Did we just move it 7 units down? Let's see. 1, 2, 3, 4, 5, 6, 7. And that was N, and it's the new N. Yeah, it looks like it. Did we reflect across the x-axis? Okay, here's an interesting one. Okay, if this is the x-axis right here, L is 1 away. This other guy It doesn't look like it. 8. Okay, we're going to dilate. Finally, we're changing size. Okay, we're going to dilate by a scale factor of 2.5. So basically, where are all these points? We have to know the numbers. A is at 4, 2. B is at 6, 4. C is at 2, 6. Use your calculator. Make these all 2.5 times bigger. Where does that end up? 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 The new A, the new B, the new C. Everything needs to be multiplied by 2.5. All right, number 9. How did we get there? We start with the normal letters, and we go 7 down. So let's see. C would be 1, 2, 3, 4, 5, 6, 7. C would move to there. Oh, no, 7 units right. How about I read the 7 units right? Okay. 1, 2, 3, 4, 5, 6, 7. Okay. Followed by translation 6 units down. 1, 2, 3, 4, 5, 6. No. Okay. C is reflected across the x-axis. So C would go, here's the x-axis. If that's the mirror, it's 1 away from the mirror. So now it would be 1 away from the mirror this way. And then 7 units to the right. 1, 2, 3, 4, 5, 6, 7. Okay, that one worked. Let's see if it does for A. A is 3 away from the mirror, so it would be 3 away from the mirror. And then 1, 2, 3, 4, 5, 6, 7. Good. B is 3 away from the mirror, so it's going to be 3 away from the mirror. And then 1, 2, 3, 4, 5, 6, 7. Looks pretty good. For C, ABC is reflected across the y-axis. ABC is reflected across the y-axis. Remember, this is the y-axis. So if B is a little bit from the mirror, its reflection is going to be a little bit from the mirror. A is 3 from the mirror, so its reflection is going to be 3 from the mirror. C is 3 from the mirror, so its reflection is going to be 3 from the mirror. And then what if we move it 7 units to the right? That doesn't look like it ends up here. And finally, number 10. How do we get from here to here? Let's see. Oh, no. Okay. This guy got moved to there by translating it 9 units to the, reflecting across the x-axis and then translating it 9 units to the right. Okay, so they went over here. What they did was go over here first. No, sorry, x-axis. Boom. Something like that. Like they moved it up here, then they slid it to the right. Okay. Is BC longer than this? No. All we did was slide. All we did was reflect and slide. I didn't change any of the lengths. Angle A has the same measure. Yeah, if we go from here to here to here and we don't dilate, everything's congruent. They're similar. They're still the same shape. Everything's good. Yes. Side CB is the length of AB. The new side CB, or the old side CB, is the same length as new side of A and B. Those are different sides. Why would those be the same? Those aren't even the matching sides. Okay. There's G. There's H. Target H. All right. I'm probably going to need a calculator for this one. What's the difference between -1 and 4? -1, 4. Okay, that's where this point is. -1, 4 is right there. And -4, 4. -4, 4. Well, that's easy. That's not very much. How far are those 2 points apart? They're on a straight line. Those are just 3 apart. That's easy. Okay, over here. Number 2. We've got a right triangle right here. Right here, look, there's the right triangle. So we've got this triangle where 10 is the diagonal. 6 is this guy over here because, look, it's 6 feet tall to where the ladder hits. And they're saying how far is it right here? So these are the A and the B. This is the C. Remember the formula? A squared plus B squared equals C squared. The diagonal is always the C squared. So 6 squared plus I don't know squared is c squared. 36 plus b squared equals 100 minus 36 minus 36. B squared equals 64. Now I want to take the square root to get rid of the squared. And some of you might be smart and say, well, b is plus and minus 8 because I know I'm always supposed to put that plus and minus sign. And you'd be absolutely right, except for the fact that in the real world, distances have to be positive. That ladder can't be negative 8 feet from the wall. That doesn't even make sense in the real world. So yes, in math, plus and minus 8 would be the real answer. But if we're using it in a real world problem, like how far this ladder is away from the house, then it's only positive 8 because negative 8 doesn't really exist in our world as far as distances. All right, use your calculator. A squared plus b squared equals c squared. All right, so take this to the second power, take this to the second power, add them together, and that's what this will equal. So then at the end, we take the square root and give me, I think it's gonna be a decimal, but I'm not sure. All right, this one, same problem as the one up here. Follow the same steps. This one, same problem, follow the same steps, but we're just looking for, so this is still the C, this is the B, what's the A? Same thing. Okay, here's how this one is done. Ready? They're saying imagine each of these was a triangle. They're trying to say, is it a right triangle? So if I had a triangle like this, now my long side is always the diagonal. So this is the longest one, so this would be the 52. The other two, 14 and 46. Okay, their question is it a right triangle? Well, if a squared plus b squared equals c squared, it is a right triangle. If we can use that formula and it works, that means it's a right triangle. So for us, if 14 squared plus 46 squared equals 52 squared, 52 squared, then yes, it's a right triangle. 14 times 14 times 14 is 196. So if 196 plus 46 times 46 equals 2,116, if that equals 52 times 52, which is 2,704, then I know I have a right triangle. But when I add these up, 196 plus 2,116, I get 2,312. And that's supposed to equal 2,704. So it doesn't work. So these three sides would make a triangle, but since a squared plus b squared equals c squared doesn't work, you see how the answers don't add up? Then this is not a right triangle. It's some type of triangle, but it's not a right triangle. It probably looks something more like that. Not a perfectly straight right triangle. All right, so here we go. For this one, the long one would be 42 and the short ones would be 9 and 6. Tell me if that's a right triangle or not. For this one, the long one would be 40, the C, and the short ones would be 24 and 32. Tell me if those make a right triangle. Same thing, just test it out. If it works, yes it is. 7. What's the distance between these points? Let's see, 2, 7 is right there. -6, +1 is right there. Okay, how far are they apart? Okay, ready? We make a triangle. That's what this whole section is about. I make a perfect triangle, and since I know these are perfectly right angles, I can do that. So this is 1, 2, 3, 4, 5, 6. This is 1, 2, 3, 4, 5, 6, 7, 8. So how much is this c squared? So this is my A and B. How much is this guy over there? Is it 5, 14, 6, or 10? You should know this from another problem already. Okay, what's the distance, if every one of these is worth 1, what's the distance between the shoe store and the clothing store? So how far is this to there? Well, it's a diagonal, so I can't just count boxes, but I can make a triangle. I can make a triangle. All right, let's see. 1, 2, 3, 4, 5, 6, 7 boxes. 1, 2, 3, 4, 5, 6, 7, 8 boxes. Okay. Now it says to the nearest tenth. Remember, tenth looks like this, So you need to give me to the nearest 1 decimal spot. All right, so same thing. There's your a squared. There's your a. There's your b. You have to find the c squared. All right. What's the difference between a and b on the coordinate plane? Okay, so from there to there, same thing. Now we're just going to make this triangle. This is just 1. This is 1, 2, 3, 4, 5. How far are they? Same thing. Okay, let's see. Triangle, triangle ABC was created by joining the points A is at 4, -6. B is at -2, 2, or 2, -2. And C is at 6, 4, 6, -4. Let's see what they're asking. The triangle ABC is reflected over the y-axis, so it would have moved, here's the y-axis, it would have moved over to here. B moves here. A is 4 away, so it's going to be 4 away this way. That's where the new A goes. C is 6 away, so it's going to move 6 away over here. So if I reflect it across the y-axis, that's where it's going to go. And then reflect it over the x-axis. Okay, so that means this is 4 away, this is 4 away, this is where the C went. B is 2 away, so it goes 2 away, this is where the B went. A was 6 away, so it goes 6 away, this was where the A went. So which sides ended up being, which sides? The side that was between B and C, this side, which side is that now? Because now you see where B and C went, which is A and C, which is A and B. All right, good luck.